Good morning. This is the last video of my Rube Goldberg project, and in this video I'm going to be explaining the conservation of energy, and I'm going to be explaining it about the golf ball rolling down the ramp during my project. So first, the law of conservation of energy states that the total energy of an isolated system remains constant. It is said to be conserved over time. Energy can neither be created nor destroyed. Rather, it transforms from one form to another. And in this particular case, we're going to be transforming from potential energy to kinetic energy. So the first formula that we are going to need is the potential energy formula. So potential energy equals mass times gravity times height. And in this particular case, our golf ball's mass is 0.045 kilograms. Gravity is 9.81 meters per second squared. And our height of our golf ball in this case is approximately 0.1778 meters. And for these problems, we need to be in meters and kilograms. I'm going to go ahead and group my numbers and my units to simplify this just a little bit. Units are very important in physics, in my opinion, and the reason that I think I feel that they are so important is for the simple fact that if we're calculating speed, for instance, and we get kilograms in our speed, we know that it's not going to make sense and we did something wrong in our formula. Now, potential energy, the units that we're finding are joules, and this actually equals a joule. So therefore, we know that our setup for our formula is correct, and we can continue on. And when we calculate, or when we multiply all this out, we end up getting 0.039 kilograms per meter squared over second squared. And again, that equals a joule. So our potential energy is 0.039 joules. We'll just go ahead and write that, I guess, to simplify. Joules. All right. Perfect. Now, I am going to show you that kinetic energy and why it equals 0. So the formula for kinetic energy is 1/2 mass times our speed squared. All right? And at the top of our ramp, the golf ball's not moving. So our speed is going to be 0, making our kinetic energy 0. Now, we're going to calculate the speed of the kinetic energy at the bottom of the ramp. And by this law, it states that the kinetic energy at the bottom of the ramp is going to equal the potential energy at the top of the ramp. So we know our kinetic energy is 0.039 joules, but I'm not going to use joules in this case. Instead, I'm going to use this formula right here, which still equals a joule, but I want to show how everything cancels to give us the meters per second that we are looking for. So this is 0.039 joules, which is our kinetic energy at the bottom of the ramp. And then we got 1/2, which is a scalar, so no unit needed. And it's 0.04, our mass is 0.045 kilograms. And we are looking for our speed. And we don't know what our speed is. So the first thing I'm going to do is I'm going to go ahead and cancel our kilograms. So we now know that there is going to be no kilogram in our speed. And then I'm just going to multiply and divide, just do some algebra here, to get v by itself. So the first step I'm going to do is multiply by both sides by 2, and we'll divide by 0.045, and then we got meters squared over second squared. and that's going to equal our v squared. Okay, and when we do this math here, that almost kind of looks like a 1, doesn't it? We'll make that a little more of a decimal. There we go. All right, so when we do this math, we get 1.7333 meters squared over seconds squared equals, there we go, v squared. All right, so we're going to take the square root of both sides. Now, when we take the square root of both sides, that's going to cancel. And so then we're going to get 1.733 meters squared over seconds squared. Okay, so the square root of 1.733 equals approximately 1.32, and the square root's going to take care of one of the meters and one of the seconds. Therefore, we're going to get meters per second, which is what we're looking for speed. Now, let's just prove that our potential energy now equals 0. So potential energy is mass times gravity. Now, our height in this matter, so let's just finish that. Mass times gravity times height. Now our height at the bottom of the ramp is 0. Therefore, this is all going to equal 0, and our potential energy equals 0. I hope this tutorial helps explain the conservation of energy, and I hope you enjoyed it. Thank you.